Okay, this will be the worksheet 24 second part video. And if I go down to the next set of questions, it's a sine wave of frequency 2.2 kHz, DC offset of 3 volts. When you select sine wave, you can put in your DC offset on the sine wave, or you could put a second voltage source that is 3 volts DC between your AC source and ground, and then you can add or subtract voltage. So you can do it one of two ways, and I don't think I need to go back and revisit that for just adding a 3 volts offset. The frequency is different than above, so your time per division, your volts per division, coming up with the times in the 1/10 of the time, and then how many cycles. That is different from the original problem. Now, my intention is to have you do it on an oscilloscope, so once you get your waveform looking like what you simulate, then you go in and see what your time per division setting is and your volts per division setting is. So, and your multiplier and your probe setting. So you've got to make sure those are the same, and so this is just an exercise to make sure that the multiplier the scope thinks it has is equal to what the probe has. So that's one of the details to properly using a scope. And then simulate it, show 4 cycles, so 4 cycles, just like we did before. When we go from a square wave, which is what I ended on, to a triangle wave, then to make a triangle wave, we want 7 volts peak to peak, and we want an offset. So our peak voltage is 3.5 with a -2 offset and 650 hertz. So let's see if we can do all this and remember. So my frequency is now 650. And so my time is, we'll just call that 0.0015 and 0.0015, so we can call that 1.5 milliseconds and 0.15 milliseconds for our times at 650. And I'll have to go back and forth, I'm sure. 7 volts peak to peak with a -2 volt DC offset. So I'm going to go into LT Spice, and I'm going to close my window because I have to change the pulse values, and I have to change my transient. So I'm going to right mouse click on my pulse. Now notice our rise time and our fall time were 1 nano for a square. So what we're going to do is our time on is going to be 1 nano. And basically we want our rise time to be half of our cycle in whatever that is, and our fall time to be around half the cycle in whatever that is. And then time period, everything else. We'll have to adjust our initial based on the DC offsets. So, but that's the big thing. To go from a triangle to a square, your rise time and your fall time change. Your time on changes to 1 nano, and your rise and fall time change to half the cycle. Whereas your time on was half the cycle, and this was your entire cycle. So let's start with that. So our entire cycle is 1.5 milli. So I'm going to go back to Spice. And so my period is 1.5 milli. Okay. My time on is 1 nano, and so now my rise time and my fall time needs to be half the period. So half of 1.5 milli is 0.75 milli. And my fall time, don't forget the M, I just about did. My fall time will be 0.75 milli as well. Okay? So instead of rising nearly instantly like we do with a square wave, we kind of ramp that out, and then we wind up with a triangle wave. That's how you do it. 4 cycles I think is good. -2, and so I'm going to go 7 volts peak to peak. So I'm going to start at, that's 3.5 volts peak. So I'm going to start at minus 5.5 volts, and I'm going to go to 1.5 volts positive, and that should be a difference of 7. So my initial is minus 5.5, and my on voltage is 1.5, and that then adds up to my peak to peak. I've got 4 cycles, so that should be good in terms of building my waveform, my triangle waveform. That is 650 hertz with the -2 offset. I want to show 3 cycles. I've got 4 checked. So now I've got to go in and put in my times in the simulation part. So this is now okay. And now I got to go in and edit my simulation card. Okay, and we said for 3 cycles I need, where are you, spreadsheet? There you go. For 3 cycles I need 1.5 milli, so times 3, I would need 4.5 milliseconds of total time to see 3 cycles, and then 0.15 milli is my step time. So my stop time is 4.5 milli. We can start at 0. If you want to see steady state, sometimes you start a couple cycles in, which just shifts everything. But when you're just starting out, just go with 0. And my maximum time per step is going to be 0.15 milli, or 1/10 of my cycle. And that should be okay. And now I'm ready to simulate it. And look at it. And what you see is we have a triangle wave. Some people call that a sawtooth, and either terminology is fine as long as you know what they're referring to. Notice I'm down about minus 5.5 to start. I'm going up to 1.5, so that gives me a -2 volt offset. And I'm going 7 volts total. So it's everything that I have asked for here. Okay? And you can do a screenshot and you can simulate it, send it to me. 11 and 12 does a square wave again. So I've done one square wave. This is just more practice. I intend to have you setting them up on the bench and showing them to me live, because one of the things you want to come out of DC knowing is how to set up the waveform generator, how to look at it on the oscilloscope, and it would be good to also be able to simulate different AC waveforms. And the 3 AC waveforms you use in most of your classes going forward will be sine, square, and triangle. And so between these 2 videos, you've now seen how to do it. I always have a hard time with these last 3 questions. If you're explaining it to someone with no knowledge in the field, how do you check current in a circuit? How do you check the resistance of a component in a circuit? And how do you check the voltage of a live circuit or in a circuit? So I want detail on these, because I want to get some sense that you know all the details, and that I know it's hard to write down all the details, but I want to see all the steps. You know, everybody wants to get through with this quick, and they'll say something, and it's not complete. If it's not complete, I'm going to mark it wrong. So just so you know, explain it to someone. So square, wave, sine, wave, triangle. Between two videos, I've done one each. I've shown an offset. I've shown on the spreadsheet that I use or have made how to go from frequency to the time, or the period is what that should be. And then the sample time is 1/10 the period. And that's a good goal to set for yourself. You can actually use less than 10. You could use 5 samples and be okay. But there is a minimum. 10's just good, and it's easy to come up with. Okay, anyway, I hope that helps. I think that's it. And I thank you for watching.